Thank you very much. Selamat petang, selamat datang to all the participants, dan salam sejahtera kepada semua. At the outset, I'd really like to congratulate the Sustainable Energy Development Authority under the Ministry of Energy and Natural Resources on hosting this International Energy Summit after what's been a long break due to the pandemic. And it really is a demonstration of Malaysia's commitment and convening power and appetite when it comes to energy transition. I'm very grateful to the organisers for inviting the Australian High Commission to co-host this deep dive, which you'll all see is entitled Managing High Penetration of Variable Renewable Energy in the Electricity Grid. I'm a former ambassador of climate change for Australia, and these are issues which I take a great interest in and which the Australian government is also grappling with as part of our climate change response. And if I can just say that for Australia, we really do look forward to partnering with countries across the Indo-Pacific region to improve access for all to affordable, reliable and secure green energy. There is much that we can do together and experiences that we can share. Here in Malaysia, at a government-to-government level, through our High Commission, we're already cooperating on greenhouse gas inventory and also doing a scoping study on the potential for pumped hydro energy storage across Peninsular Malaysia. Very importantly, I'd also like to thank and recognise all of our panellists who are here today. John Grimes is the Chief Executive of the Smart Energy Council of Australia, who's come from Australia for this workshop via India. Ingenieur Shanmugam Thopalan, Head of the Grid System Operator of Malaysia. Dr. Arshad Salama, Senior Lecturer and Course Director for Master of Applied Engineering at the School of Engineering at Monash University, Malaysia. And Dr. Veronica Shabunko, the Head of Market Development of Southeast Asia, Gresenbach Envalon in Singapore. And I could just ask you to put your hands together for all of our panellists. I will give a bit more information on their bios before they speak. But the topic of this workshop really is fundamentally important to all of our countries. Australia and Malaysia and other countries in the region, we've all committed to net zero carbon emissions by 2050, and we all have ambitious 2030 targets as part of our nationally determined contributions under the Paris Agreement. For Australia, our new government's increased our ambition to reduce greenhouse gas emissions by 43% below 2005 levels by 2030. And all of our countries are looking to introduce suites of new policies across our economies to drive this transition to net zero. Just in Australia's case, this includes an investment of 20 billion Australian dollars to modernise our electricity grid and increase the portion of renewable energy in our national energy market to 82% by 2030, up from 30% today. And that will be achieved by both residential and rooftop solar, where more than 1/4 of Australian households already have solar panels, and solar farms, where we now have more than 49 farms constructed and a further 52 under construction. Australia will also see an increase in wind energy, where there are currently 21 large-scale wind projects under construction across the country. And to support this influx of renewable energy, the Australian government is also distributing community batteries and solar banks across Australia for households that can't install rooftop panels. At the same time, as well as bringing that more renewable energy into the grid, there'll be extra demands on electricity, including through electric vehicles, with a doubling of investment in charging and refuelling infrastructure under Australia's first national electric vehicle strategy. So in that Australian example, that rapid transition to renewables will be built upon an electricity grid, which up until now has largely been built for large-scale fossil fuel generators in mind. And that, of course, is a challenge that most countries will face, and it's a challenge that we're really looking forward to hearing from our panellists today on how we address that. So I'm very pleased that we've brought together a diverse group of energy planners and experts from Australia, Malaysia and Singapore who can provide further insights into the opportunities presented by variable renewable energy, but also identify the challenges and strategies to manage that transition. I'll be asking each of our panelists to speak for about 10 minutes, and then after that we'll have Q&A. I propose to throw very quickly over to the floor, so I know there's lots of questions and lots of expertise in the room today. So to commence, and to offer a more detailed overview of the transformation of Australia's electricity grid, our first speaker is John Grimes, the CEO of the Smart Energy Council. The Smart Energy Council is an independent body in Australia that seeks to accelerate Australia's renewable industries for economic development and which conducts advocacy for industry on the benefits of smart energy solutions for all Australians. John also sits on a number of Australian government boards and expert reference committees and has a passion for renewable storage and renewable hydrogen industries. John's presentation is on managing a renewables grid, and I'll invite John to come up. Thank you very much.
Well, Excellency, the organisers, ladies and gentlemen, it's absolutely fantastic to be here with you today. So I'm going to give you a quick presentation about high penetration renewables in the Australian grid. Okay. Let me begin with this little case study. So this is the jurisdiction of South Australia. So this is not the whole of Australia, but it is a fairly significant state in our country. And you can see in 2005, there was essentially no renewable energy in the South Australian grid. By this year, 2022, there is 68% renewables. And by 2028, they forecast that the entire grid will be powered entirely by renewable energy. So this is a massive transformation happening in real time. And so we as a nation are learning about the challenges and opportunities of managing that degree of variable renewable energy in our system. Here's an interesting slide. This was actually October last year. And you'll see on this slide that for part of the day anyway, 100% of South Australia's energy needs were met by solar energy alone. Not solar and wind, but just solar. And of that, 77% of that generation came from rooftop solar, from solar panels on people's homes and businesses. The rise of rooftop solar in Australia has been quite phenomenal. In fact, there are over 27 gigawatts of solar PV now installed in Australia. About 13 gigawatts of that is small-scale household solar PV. About 60 million solar panels deployed. 2.5, actually it's 3.5 million systems. So what we're seeing in Australian homes is that people are embracing solar because it's so cheap. To buy electricity from the grid costs on average 30 cents Australian per kilowatt hour. To produce solar on your rooftop, amortised over 20 years, costs about 5 cents per kilowatt hour. That's a massive saving. So it is economics that is driving this transition. But households are now going further. They're thinking about, how do we cut the gas? How do we do water heating with electricity? How do we do space heating with electricity? How do we do cooking with electricity? It's called the electrification of everything. And if you look in the garage, you add in an electric vehicle, and suddenly you're slashing your electricity bill with renewables, getting rid of your fuel, your gas bill, and getting rid of your petrol bill, and bringing the cost of living right down. So what that means is that the electricity grid of the future is going to be much bigger than it is today. Because we're taking electricity, we're going to take all of that gas load and we're going to actually put it onto the electricity grid. We're going to take that massive fuel load in petrol and diesel and we're going to put it onto the electricity grid. And if we can power that with renewable energy, we can bring the price down and also slash emissions, which is a key goal. Now, this is the work of the Australian Energy Market Operator, AEMO. These are the experts that run the energy system in Australia. This is their figures. And what it shows is what's happening to the energy system in Australia. You can see 23, 24, down the bottom, there's black coal and there's gas in the system. And the further we go out, what you see is the transition is happening. Two things is happening. Look at the size of the energy market, the electricity sector, growing enormously over the next couple of decades as that fuel switching happens. Second, look at the portion of fossil fuels in the system, actually diminishing. So AEMO says that by 2030, 60% of coal will be out of our system. By 2043, they predict that 100% of coal will be out of our system. This is a massive structural change happening in real time. But as I said earlier, this does create some challenges. So the South Australian Power Network, SAPN, they manage the distribution network in South Australia, are finding now that actually almost 1 in 2 homes in South Australia has rooftop solar PV. So all of a sudden, in the distribution network, almost every substation is experiencing reverse flows of energy. Well, the distribution network was not designed for two-way flows of energy, right? And so this creates, how do you manage this, right? First, how do you know what's happening on the distribution network? And secondly, how do you manage it without having to spend billions of dollars upgrading the infrastructure? Now, the really good news is we're learning by doing. We're actually learning in real time. So managing dynamic exports of solar energy, so dialing it up and down, giving the operator control over the amount of energy, and in extreme situations, giving them a solar shutoff, right, to help stabilize the grid. These are all so smart IT systems, real-time intelligence. This is really the future of the grid in Australia. It also means that we've got to shift our load. You've all heard of the duck curve, right? This is where you get low demand in the middle of the day and then peak when everybody comes home. Well, our job at the moment is to stuff the duck, to take that demand from other parts of the day and put it into the middle of the day where the solar resource is so fantastic. And so that means electric vehicle charging in the daytime. It means hot water heating in the daytime, right? We've got to get smarter about how we balance and manage the grid. The next thing that we've learnt in Australia is that it's all about storage. Storage, storage, storage. Now, that's at every scale. It means we need to do big pumped hydro projects like Snowy 2.0. We need to put in interconnectors between the big hydroelectric dam in Tasmania and the mainland. We need to put in big batteries. Do you remember Elon Musk and Mike Cannon-Brookes had a bet on Twitter, right? Well, Elon Musk said, we'll give you a battery and we'll build it in 100 days or it's free of charge. Well, within 96 days, the big battery, 150 megawatt battery, was in place. So we're also doing much bigger batteries than that now, and that trend continues. The next thing we need to do is build the transmission lines of the future. In the past, we built from a coal-fired power station to the city. Well, now we've got to build transmission lines to the renewable energy resources, the solar and the wind. And that's why there are 13 renewable energy zones being built out in Australia right now. Here's the kicker. You put a solar panel in Australia, you put the same solar panel in Germany, South Korea, Japan, the one in Australia will produce up to 2.6 times more energy every year. I'm not talking about a 5% incremental difference, a 10% efficiency gain, 2.6x, right? Huge, huge difference. That means we've got so much land. We've got ports, we've got export relationships in place. Australia will be one of the hubs of the future for creating and exporting renewable energy. And this is, I showed you this slide before. This was IEMO's forecast of the energy market. Well, this is their renewable hydrogen superpower forecast. Green hydrogen, zero carbon hydrogen being produced in Australia. The Smart Energy Council has a zero carbon certification scheme where we certify renewable energy hydrogen projects. We've done that for a refueling station and for a green ammonia production facility in the Pilbara. We'd love to work with Malaysia to actually certify a renewable hydrogen project here in partnership with you. The Smart Energy Council is a peak industry body. We represent 1,000 companies across the ecosystem in Australia. If you want to learn more about entering the Australian market, we've got a big conference and exhibition on the 3rd and 4th of May next year in Sydney, our 61st annual conference. And look forward to the discussion. Thank you very much.
Thank you very much, John, for that introduction and that focus on Australia. I'm sure there's lots we can follow up on. But I'm delighted that now our next speaker is Ingenieur Shanmugam Thopalan, the head of the grid system operator in Malaysia, which is responsible for the day-to-day real-time operation and management of the Peninsular grid system, together with the short and medium-term planning of the transmission network and generation facilities, which includes interconnections with Thailand and Singapore. Ingenieur Shanmugam's presentation is on managing higher penetration of variable renewable energy in a grid, and we look forward to getting the Malaysian perspective. Ingenieur.
Thank you, His Excellency and members and also colleagues here. I think after hearing Mr. John, I just changed the title. It's not managing high, it's just integrating solar renewables. Actually, I'm quite humble to share the stage with Australia here because I can say that we are still very, very low in terms of penetration. And I think you all are way up there. So we are a lot of learning to do from Australia, I believe. So today, I'll just share how in Malaysian context, how do we integrate solar into the system. So basically where we are now, 2022, August, this is where we are. You can see the black line is where the system demand at the grid level. Above that is distribution and below that is transmission. We are just about 2002 gig, 2.2 gig now, which is, I would call that very, very mild in terms of the numbers that AMO showed just now. So I think so far no issue. We are doing just fine. And this is where we are at this point of time in terms of megawatt. In good days, we can get as high as 17, 18. And in terms of energy, we are good to displace 500 megawatt coal. So basically, we have successfully displaced close to 5,000 metric ton of coal a day. That's what we have done so far. But this is just the beginning of our journey. I think as today's session in the morning, you can hear the aspiration that even directly shared by our Yang Berhormat, the Prime Minister. Basically, 2025, this is where we're looking at. On a good weekday, we are looking at 31%. On a Sunday weekend, we're looking at close to 45%. So this level of penetration is doable, feasible, only because we are very, we're taking a very systematic approach. The governance is very good, and how we connect solar, where do we connect solar is very important for us. And I think all of us are very well aware, Malaysia, especially Peninsula, is very solar centric. So at this point, up to this amount, 6 gig, we can do safely with the existing, leveraging existing assets, So we are not going into the enablers yet. So basically, how do we do? How do we able to integrate 6 gig of solar? So this is how we do it. Basically, as we all aware, how do we make the solar behave as a conventional? I think the power electronics technology is moving quite positively. It can mimic a lot. And what we are doing is, we're trying to solve what could be the main concern, the frequency, the voltage, and also system strength. So basically, we are emphasizing on strong compliance of the solar facilities, especially LSS, the one which is directly connected to transmission system. And this is where the topology is. We can see that the network, we have quite invested in our network. I can say that our backbone is very solid and our infra is good. We can basically facilitate solar connection quite across all over the states. So basically, how do we manage? We need to check the power transfer when we shift from 1 o'clock to 8 o'clock, where the demand picks up without any solar. How we safely ensure the power transfer is safe. How do we manage a conventional facility? Flexibility. I think a lot of gas turbine and coal owners are here, maybe, just to, because they've been relatively very flat, flat dispatched. So going forward, they have to move a lot. So how do we manage the flexibility? Works on ongoing, how to manage interconnections, very important, how we leverage on our interconnections. And with all this combined, we will manage the regulation and the balancing. But of course, behind the scene, we're also checking how do we move forward in terms of wide area monitoring and wide area protection. So basically, firstly, we do a study, how they connect. Is it safe, the connection? So once we have done well is that so far all connected LSS have no curtailment. They can export full capacity at all time. Yep. And then we ensure compliance. They have to give a strong support in terms of frequency, voltage, reactive power. So we have nearly 25 LSS connected in the system at this point of time. So basically it's good. So far they are performing very, very well. And finally, how do we use them? Now we use the solar as well, to support the grid. So we use the reactive power, we use frequency support. For now, high frequency. Maybe in the future, we have to use low frequency as well, like what most utilities are already doing. But we have tested for them. They have the facility, they have the capability to do both sides in terms of frequency. And most importantly, we want all our inverters to be able to ride through. So this is a fundamental aspect of our grid security. All inverters, whether LSS, distribution, rooftop, all must be able to ride through. So this is an aspect of it. And then, how do we support this solar? This is where we use hydro. We have about 2.5 gig of hydro now. So they're going to work hand in hand with the solar. They're going to be the partner that's going to shift, which is conventionally, the hydro used to do the peak shaving. Now they're going to move to the night, where the solar comes in at the daytime. And then, of course, the gas and the coal are relatively a very young asset. A lot of new builds in the system. I'm sure that they can do the flexibility in terms of balancing. And the most good thing for Malaysia is that we are very solar-centric. So one thing what we notice here, they are very predictable so far. Of course, we have to work on the engine. So far, we're doing quite good. We can get up to single digit. And lastly, we have to leverage on the interconnection. So far, we're connected with Thailand and Singapore. So we have a new connection, nearly double the capacity with Singapore. So this is our forecasting. You can see a lot of concentration of the solar is in the north and the east, whereas a lot of conventional are actually in the central and in the south. So we have a good, what we call it, the load predominantly in the central and also south. So basically, what will happen, we guess, is that the LSS will go to the north and the east. The rooftop, the Celcos will go to the central and the south. So we hope to get a good balance all over, and the penetration is quite harmonious, I believe so. This is what we expect, at least when we reach the 6 gig in 2025. And if we can increase further the interconnections, something that I think most utilities or more countries are leveraging on interconnections. So far, the interconnection that we have with Thailand, I think we have outgrown the size. IGAT and PNB, we have outgrown. It's a very small interconnection, 300. And it's about time, I believe. We need to look at the interconnection. So basically, we have quite a diversity in terms of wind, solar within the ASEAN countries. I think a strong interconnection among ASEAN countries, we can leverage on the variety of renewables. And at the same time, there's also time difference. There's quite a 1 hour difference with Thailand and Vietnam. I believe we can leverage on all that. And I believe we also can leverage on any interconnection that Singapore may build in the future. Because we are in Singapore very close. It's hardly can be said as one good AC system. So basically, a way forward is how do you support beyond 6,000? This is where we have to bring enablers. I think it's quite widely talked about. I think the numbers that's shown just now, just a few minutes ago, quite super hydrogen, I believe, and also all the batteries. So basically, this is where we have the lead. We have a good 2-3 years for us to work on our enablers. Basically, the fundamental enablers that we are looking is at, of course, battery, demand response, and not to forget curtailment. I think curtailment is one element of enablers. It is normally we should start with curtailment and then evolving slowly into storage and so on. As long as we don't curtail a huge amount of the solar within the first single digit, I think should be fair and reasonable. I think so. This is where, as a JSO, we need to be prepared. So our context here is actually to say that a lot of things may not be within our control, especially like how you shown the rooftop, how it grows. We are not sure how Malaysian appetite for rooftops. If suddenly it grows, it may go beyond what we actually envisage. So in all sense, as a system operator, we have to be prepared. We have to have the means to visualize and to prepare for future high RE penetration. So for now, I think that's all. Thank you.
Thank you very much, Insigneur. Our next presenter is Dr. Arshad Salama, the Senior Lecturer and Course Director for the Master of Applied Engineering at Monash University, Malaysia. Arshad is passionate about renewable energy, process design, and the development of thermochemical systems, microwave processing, energy efficiency, and sustainability. Very appropriate now to hear from Dr. Arshad with his presentation on managing solar energy for the commercial sector using demand scheduling and artificial intelligence. Dr. Arshad, can I invite you to the microphone?
Assalamu alaikum and very good afternoon. Thank you, His Excellency, and all the panelists and organizer. Okay. As compared to our previous presentation, I would like to more focus on case study, what we have done it on commercial sector using the real data. So I would like to present 2 case studies that we did on electric buses depot, as well as commercial building itself on our Monash campus. So managing solar energy for electric bus depot, around 45% of Malaysian energy is consumed by transportation sector, out of which this transportation sector emits around 70 million metric tons of CO2, maybe more than that. This is 2015 data. 85% of this emission comes from road transport. All of us wish, I mean, we believe that because we know how our road transport is heavily dependent, I mean, on transports like cars and vehicles. Some game changer here was electric vehicles or electric buses to be implemented. So, but we have to charge these electric vehicles using the grid. Grids are mostly dependent heavily on fossil fuel, especially in a context of Malaysia, if I'm not wrong, around 40% dependent on coal. 65. Okay. So, and the fraction of renewable energy in our grid is very less as compared to other countries. Another problem with this electric vehicle is load demand. Okay. So when we charge our electric vehicles, they consume a huge amount of current at one place, and that creates a load demand on the grid, and that is shown here. And the peak, whenever we charge, here is shown for the buses. And that comes in the electricity bill when it comes. Okay, so we have two tariffs here for commercial. One is kilowatt hour tariff, that is 36 cents per kilowatt hour, and one is for maximum demand, that is 30 ringgit per kilowatt. So usually the operator, the depot operators, they are more concerned about this maximum demand because that creates a additional bill because of charging the buses due to the load. We carried out a study for this bus depot, and we implemented a solar PV plant for it. As mentioned by our previous presenter, I mean, the maximum solar is available in the daytime. Okay, so what happens now, as business as usual, they are actually charging 6 buses in the night time and 4 buses in the daytime. So this is the current business as usual of the charging of the buses. Depending on it, we try to do the techno-economic analysis for this present scenario. And we found out that we have to implement, let's say, for example, 425 kilowatt peak solar PV system with a capital cost of 1.5 million ringgit. Payback period, simple payback period of 9 years with utility bill saving of 170,000 ringgit per year. So this is depending on the business as usual. What we did is, we try to change now the bus charging routine. Okay, so what we were charging, let's say for example in the night time, let us recommend to charge in the daytime where the solar is more available. So we change the bus, we recommend to charge the buses in the daytime and increase the load, the peak load in the daytime, so that we can implement the solar PV system of 850 kilowatt peak with a capex of 3 million ringgit, payback period of 8 years, and utility bill saving of 365,000 per year. So in the next slide, I will show you the variation. So this is before changing the bus charging routine, the electric bus. So this is, you can see in the basically these two are in the night time, the yellow color, and the blue color is in the middle is the daytime, basically the charging, the load, and the greenish yellow is in the night time. So this is before changing the bus charging routine. And this is basically the profile that we get. Okay, so the red color is the base load that comes from Tenaga Nasional Berhad, the base load that's come from the grid basically. So if we implement solar in the daytime, that will help us to decrease the what we call as the base load at around 450 kilowatt. We can decrease by implementing the solar PV in this scenario. So we have done it for the whole year, but I have shown certain months only. And worst case scenario, I have shown you that see how variable the solar energy can be. So in some days, in rainy season or the cloudy season, it can be, you can see the production is not much high in the especially in December and January, November, December and January, it can be very low. Okay, so this is one scenario. But if we change now the bus charging routine, bring the buses more in the daytime charging, and bring the peak load, you can see the greenish yellow color in the middle now of the day at 12 p.m. in noon or 1 p.m. Then this will be the scenario. We can see that we can implement more solar PV and reduce the what we call as demand, the peak demand or the load demand, maximum demand of the electric bus depot by around 600 kilowatt. So this is the difference between changing the bus charging routine or changing the scheduling, properly scheduling the charging of the electric vehicles and how we can manage it properly. So this is another case study that we implemented, and basically we applied artificial intelligence. So there are around 4 million buildings in Malaysia. One of them is our own campus, Monash, Malaysia, situated in Bandar Sunway, is under commercial tariff. This is our load profile. This load profile is very different than what you saw the electric bus depot So in the night time, of course, we don't have anyone in the offices, but our now load is in the middle of the day at around 11, starting from 9 a.m. until 4 or 5 p.m. That's where we get more demand. This is solar irradiation for the whole year in Malaysia. You can see here at the bottom that we have maximized. So you can see it's between 3 and 5 kilowatt hour per meter square available for Malaysia, I mean average between this range. So we have implemented solar PV panels on the rooftop of our buildings in Monash campus, about 300, and we generate about 302 megawatt hour, which is around 2% of the electricity of Monash. And this graph shows the target value and the production value. So the blue bar, you can see the blue bar small there, they are the target value that from January to December, this is our target that we calculated before designing the solar PV. And usually most of the solar service company, they do this, that they have some kind of mechanism to do this, to calculate the target even before implementation or before designing the solar PV system. So that is the target. And you can see most of the time the target has been achieved, except in some months that the target cannot be achieved, and some months the target, I mean, there was excess production more than the target. So that can compensate the other months also, basically. So the capital cost for this installation was 750,000 ringgit. Payback period is 7.5 years, and we get we save utility bill around 110,000 ringgit per year. So this is artificial intelligence, basically, that we implemented on this solar PV plant. Okay, so if you see the dotted line, the blue color dotted line is the actual solar PV production. And the other solid lines, that is orange color, red color, and purple color, I hope it is purple color, all they are artificial intelligence model or simulation. And you can see most of these artificial intelligence model, they really follow the actual production. The pattern, the profile, they really follow the actual production. So this is how, this actually we predicted this for 1 day only, 24 hours. So what we did is 25 days of the month, we trained the data in the artificial intelligence, and 4 days we did the testing, and for 1 day we did the prediction. And this is the prediction data that we got for different months, for February, August, November, and June. This is for 1 whole year. That is the big data. That's what we are talking, that how we can convert this big data into really a good prediction model. So this is for the whole year, the solar irradiation and actual power, AC power production from solar PV plant in Monash. And from here we model a equation that can help to predict the solar PV in future. So that's all from my side. Basically, these 2 case studies. Thank you. Thank you very much.
Thank you very much, Dr. Arshad. And so now our final speaker is Dr. Veronica Shabunko, the Head of Market Development for Southeast Asia for Grenzebach Avalon in Singapore. She's a specialist in high-performance building integrated photovoltaic systems, techno-economic solutions, and reliable integration of renewable energies into buildings on an urban scale. She's also a country representative in the International Energy Agency Photovoltaic Power Systems Program, was previously head of the BIPV Centre of Excellence at the Solar Research Energy Institute of Singapore, and a guest lecturer at the National University of Singapore, and an instructor at BCA Academy for Professional Training Programs. Dr. Veronica, I'll ask you to the microphone to give your presentation on scaling up innovative solar technologies for net zero future.
Good afternoon, ladies and gentlemen. Thank you very much for this great event and invitation. I would like to thank SEDA for the great invitation, and So today I'm going to speak a little bit different from technological point of view and share with you some innovation in solar and Singapore perspectives. But before I move on, let me introduce to you Envilon. This is a German company that I represent. So we are a corporate venture with over 150 years of experience in industry and strong parent company Grenzebach. So Envilon is like a startup. So we just started in 2021, and we had 22 people in Europe, United States, and Singapore. And we are transforming conventional buildings into sustainable power plants by integrating innovative solar solutions into facade that could generate electricity and support carbon neutrality pathway. The innovative facade system from Envilon integrates colorful PV modules into the building envelope, and this means that every building can generate clean energy and be sustainable. As mentioned, in the past 7 years, I've been a country representative for IEA PVPS, and I would like to share with you some of the information, how we work on building integrated photovoltaics. And the objective of this task 15 is to create enabling framework to accelerated penetration of BIPV, as well as working with regulatory, economic aspects of these innovative technologies and respective issues with aesthetic reliability. So please free to join. I think Malaysia is not yet joined Task 15, so these are the details of task managers, Helen, Rose, and Francesco. And here you can see 5 main subtasks that we are working on, and I have been leading the one of the activity on fire safety, which led later for the national standardization or establishment of national regulation in Singapore for building integrated photovoltaics. So in Asia, we are first country who has specific regulations how to place this technology into facades. And finally, I would like to share with you a few latest reports of IAPVPS on BIPV, so you can check out what it is, how it works, and how it can be integrated. Now let us look into Singapore context. Singapore has launched Singapore Green Plan 2030 as a part of decarbonization and sustainability efforts. Decarbonization of energy system and adoption of low carbon technologies will be essential to achieve carbon neutrality and energy security in the countries. Obviously, solar power is one of the most viable options for us. However, there are some limitations that we all know with Malaysia, for example, same climate conditions. By 2030, it is we are going to install 2 gigawatt peak of solar installed capacity. And back in 2020, I was a co-author of National Roadmap, Solar Roadmap Update, where we were assessing various areas of PV in urban areas. So you can see here different applications such as rooftop, facade, mobile, land-based PV, floating infrastructure PV. And if you can see that facades, and you know, Singapore is a mega city, right, with tall buildings and everything. So with the facades, we have about 56 square kilometers of area where we can introduce solar. So it's a huge potential and huge market, not only in Singapore, but in all large mega cities. So in densely populated cities and megacities, BIPV will be gaining momentum. And here you can see some solar modules that integrated into the building facades at the part of the structure. So in fact, you cannot see that it's solar. It looks like normal cladding. However, it is active facade that generate electricity and can use as a electricity consumption in your building. So BIPV applications are not limited to facade. It could be cladding, it could be balcony, it could be windows application. And it's important component to reduce CO2 emission in built environment and achieve zero energy and plus energy buildings. Here are some examples of BIPV projects that we have done at Envilon. These are mostly European projects, as we heard today in the morning, that energy security issue is very high in European country, and in built environment, it's like really crazy on installation of solar, whether it's vertical or horizontal or agrivoltaic. So in this case, we have quite a lot of clients who are doing logistic buildings, apartment buildings. Again, as you can see, the color of the modules are not as standard, so they have different colors. We have 10 different colors that can be aesthetically pleasantly integrated into the facades. So this is also one of the big project, 1,500 meters square of facade. In Europe, and this is our headquarter in Hamler in Germany. So this is 250 meters square of gray color facade. Again, it does not look like solar. So in general, in future buildings, we'll see more and more solar active facades, which will generate electricity and provide CO2 reductions. Okay, so in summary, the future is bright, and there are a variety of urban solar applications available. There are a variety of solar technologies available, and urban solar application is ever growing due to increased urbanization globally. With that, I would like to thank you, and if you have any questions, feel free to contact me. Thank you. Thanks.
That's great. Well, thank you very much, Dr. Veronica. So we'll now move to question and answer. I'll open the floor shortly, so please just consider what questions you might like to ask. Just before I do that, I might throw a couple just myself that have come up through the conversation. Really want to again thank our panelists all for very interesting presentations. I guess what comes out to me is certainly the potential and the opportunity and really the direction that we are going, that of course, both in terms of commitments that governments have made around getting to net zero for various economic reasons, the economic drivers behind it, the technology now being available, that this is happening, this transition to variable renewable energy. And how we manage that is one of the real key tasks to be managed. I want to ask all of our panelists, but including John and Dr. Insinyur Shanmugam, when you talk about learning by doing, as more of this comes on, just how big a challenge actually is it? And we heard that there's in Australia a lot of rooftop solar coming on, systems that were built for the fossil fuel industry. I'm interested in whether getting people to adapt the system so that people are using it at times when the electricity is available. Is this just something where the solutions are going to come through IT solutions, artificial intelligence? And so as consumers of electricity with rooftop solar, we can just rely on those managing the grid to manage it for us, that we'll just be able to adopt the technology and this will happen, and it's quite straightforward. Or does this require behavioural change? Will there be other behavioural changes that consumers will have to undertake, which will involve education and therefore will be more difficult to achieve? And is these soft systems, the artificial intelligence and the systems that allow the load shedding or the sharing of the load at best times, is this expensive? Is it quite straightforward? What has been the experience? So I'm just very interested in how big a challenge actually is the management of the system that you've been talking about. How expensive is it? How much behavioural change is needed? Or will it just all magically happen for us? So maybe John and Insignora, I'll pass it to you on that.
Well, most people don't think about electricity or energy at all. In fact, maybe that's not quite right. They think about it when the electricity bill comes. and that's how it should be, actually. People don't want to be managing their energy system minute by minute, hour by hour in their day, right? We've kind of got busy lives. There are other things for us to do. So I think that whatever we put in place, the technology is coming. I'll give you an example. One of our members does managed EV charging. That means that you plug your car in when you get home at night. They monitor the market overnight. So the car doesn't start charging automatically. Actually, they send a signal and they say at 2 a.m. when the price is really low, right? Charge now. And so it will charge in a 5-minute block, a 15-minute block, a 20-minute block, because it knows that it's got until 6 o'clock the next morning to be charged sufficiently for the day, right? So you extrapolate. They're the type of solutions that are coming. They're software, they're going to be integrated, they're things that people won't need to think about doing. There's another company called Powerledge, a great Australian company that's doing peer-to-peer trading of energy, right? So if you've got excess solar and I've got a deficit, well, let's have a contract between us, right, to actually use that energy to the best degree. These are the solutions that are coming. Inverters that respond to the distributed network operator in real time, right? So smart grid, smart meters, and smart inverters kind of responding to that. So that's absolutely where the future's taking us. What we need to recognise, though, is that the grid is a community asset. We want to get the best out of it from a private point of view. I bought an EV, I bought a solar system, right? But we also need to get the best community benefit from it, right? Because together, the EV is a 60 kilowatt hour battery in your garage, right? We could harness that and actually improve the grid, bring down the cost for the entire community. So it's about getting the policies right, the technology will follow, but that's absolutely the future that we're headed to.
Hello? Oh, yeah. All right. So a good example of technology glitch. So as a system operator, because basically nobody is actually off-grid except quite the remote areas. So as long as you're grid connected, this technology for us is fundamental. Behavior is a bit too chance on it because we can't chance the grid based on behavior. So I believe we need to support the technology with regulation. Because I think regulation is important, especially in the absence of a market signal, price, because we are not in full market yet. In the absence of strong price signal or strong tariff incentives, it's important that the access or the grid need to be balanced. So basically, like when I see the ISP plan, where you have, I think about 2/3 of storage is at distribution, at the source end. So it's important that we have technology that can able to communicate with all these resources, because we have to leverage all resources, not only at the grid connected, because fundamentally, in the long run, I believe from the plan that at least I saw just now, that John shared, 2/3 of energy sources will be at distribution, and maybe also storage at there as well. But the thing is, everybody is still grid connected, and they come back to grid whenever they are not there. So this is very important to govern how the charging, discharging, we should have the technology for it. And of course, a big shift in the role of DSO in the local context here. The distribution system operator have also to have the equivalent communication and technology. So basically, we need technology plus regulations going forward. That's my view.
Okay, well, I am going to open the floor up now. If those have questions, please, if you've got a question, stand up. I think we've got a roving microphone, and just introduce yourself and then ask your question. And you might direct it at a particular panelist or the whole panel. So just clarify that as well. So
yeah.
please,
Yeah.
you
Just raise your hand.
questions.
Okay,
Here we are.
Okay, we're bringing it to you now.
All right, good evening. Testing. Okay. Okay, my name is Christopher. I'm a environmental graduate from Curtin. I have the question for the honorable panel. Hope we're not going in a tangent. Okay. In the context of Malaysia's grid system, what are the challenges of large-scale sector coupling or hybridization with VREs, not only in terms of technological feasibility and efficiency, but also in terms of logistics, accounting for construction and operation and manufacturing costs, maintenance costs, sorry. Yeah. Thank you.
I need you to rephrase. Not clear.
Okay. Not only in terms of technological feasibility and efficiency, but also in terms of logistics, accounting for infrastructure, operation, and maintenance costs.
So that's the bringing on of renewable energy. So what are also some of the other constraints to it?
Yes.
So in terms of infrastructure, the other things that you mentioned there. So not just around the technology, but around some of the other limitations to the bringing on of renewable energy in the Malaysian grid.
I think you're talking about the enablers or the source of renewables. I think with regards to source of renewables, the investigation ongoing for other elements. The organizer of today's event, SEDA, is looking at other options, waste to energy, mini hydros and biomass, biogas. But I think the growth there is not as rapid as solar. Solar is just moving ahead of time. And of course not in international standard, but even in Malaysia, there's really a very strong uptick. Of course, slight glitch this year, I think due to the issues with the supplies. But after this, I think solar going to really pick up. So in terms of technicality, solar is far ahead compared to other elements. But in terms of maintenance and so on, I think solar so far so good. There's really hardly any issues with maintenance. And I think the efficiency also growing. The performance so far so good. I think with regards to solar is the fundamental challenge worldwide and also to our grid is how to firm it. How to firm it, now we are talking about good 5-6 hours, how to firm it to 6 hours, 8 hours, and possibly even up to 12 hours.
I think your question was on logistic transportation.
In terms of building the necessary infrastructure to support it.
Building infrastructure for renewable energy, you mean?
To support, yes.
Yeah, and related to environmental impact, that's what your concern is?
No, mostly for challenges towards the feasibility, meeting the goals, yes.
Yeah, of course. So if you talk about renewable energy, so implementation, I think solar is very straightforward as compared to other renewable energy. As you compare with, let's say, biomass plant, waste to energy as mentioned, or hydropower station and other. So wind turbine and solar are the most straightforward to implement in terms of infrastructure and all. And they can start generating the electricity as soon as they get the source. So this is for solar and wind. But For others, that's really a lot of things needs to be taken care even before implementation of their, let's say for example, biomass, bioenergy, or waste to energy, or hydropower station. A lot of things to be taken care before their implementation or infrastructure even there. Yeah.
Okay, thanks. So we have another question there. Thank you.
Hi, my name is Vijay. I'm from Destiny Energy from Singapore. This question is for Mr. Shanmugam. When the renewable energy, like solar penetration, increases in the grid, there's always a significant requirement for reserve allocation to manage the frequency. How is that being planned in Malaysia? And especially, is there any room for significant introduction of battery storage to manage the frequencies?
Okay, so basically we have tracked, if you see how solar profile have grown up to about 2.5 gig now, what we notice, there's a quite good interbalancing taking place. You know? The intermittency change and with the solar capacity, there's not linear. So we see to a certain extent now we are in a good spot. I think up to 4,000 megawatt will be still at our very sweet spot, you know, where with still no issues. I think safe to say that the support service for frequency regulations is very much, we are quite focused on the forecasting, like I think the artificial intelligence. We're also working on our own, we're also doing machine learning. So as long as we have good forecasts, we can do the regulation and the frequency balancing. So, but the future storage that comes in, we foresee that they may play a dual role. Besides firming, they may also give some form of regulation or balancing. Even at certain period, if you notice, the ramp up over Sunday could be up to 8 gig, maybe even provide a ramping support. So this is why I think back to the first question earlier, how do we leverage all the resources that invested across the system to provide this ancillary support, we call it, which is I think your question. It's interesting because at this point, without the ancillary market, we have to structure, because of course it won't come for free, right? I believe. So none of the asset owners will give it. So I think we have to work, the regulator have to work a certain kind of commercial framework. How do we incentivize? How do we incentivize these service providers? But definitely this is one element of aspect of JSO that we want to leverage on. How do we leverage on all this asset to provide ancillary services back to grid? But not now. We are looking somewhere 2025 onwards.
Next question. Anyone else?
Maybe I'll just...
Oh, okay.
Oh, no, we have one. Yep, please.
Good afternoon. I'm Hazril from Seda Malaysia. I think my question for Dr. Veronica. Just now you have shared about VRE features. So maybe if you can share how much actually the impact to the module performance after the aesthetic element added to the installation.
Just don't touch any button, they will unmute it. Is there a red?
Hello.
Okay.
Hi. Thank you so much for the question. So the question is, as I understand, what's the difference between horizontal and vertical efficiency? Impact in terms of thermal or energy efficiency, performance-wise. Yes, so when you install panels, they are almost similar as a cladding, for example, glass technology with a cladding. Of course, performance of on the vertical facade, as it's 90 degrees, it's not looking up to the sky, it's 90 degrees vertical. So in Singapore, we lose about 40%. But if you holistically look into any new development that is started right now, You install just normal cladding, you get nothing. You pay for your building material and you get nothing in 30 years. However, if you invest a little bit more for solar system on your facade, in 30 years it will, I don't know, the payback could be 7 years. And then after 7 years you will be obviously earning money, plus considering now energy prices, it's a really good business case for the building owners. Plus, of course, CO2 emissions and all the green companies that, for example, RE100, who want to be in this field, that could be supported. Did I answer your question? Yeah. Thanks.
So if there are no more questions, oh, okay, now, okay, the lady at the back, she raised her hand up first, yeah. Yes, ma'am, we are bringing the microphone to you. This will be our last question.
Hello, I'm Shahira from the University of Nottingham. I have one question for Mr. Shamugan. You mentioned earlier that Malaysia is heavily reliable on solar energy as renewable energy. But in terms of energy production efficiency, it may not be very efficient due to Malaysian cloudy climate. Do you think Malaysia is any near to reaching in combining different renewable energy in electricity grid?
Just the last one, please.
Sorry. Okay. So do you think Malaysia is any near to reaching in combining different renewable energy like hydropower, solar, what Australia is doing in their country?
Yeah, I think hydro definitely, but I think the available mini hydro sites are quite limited at this point of time. I think the large one is also being developed, the newly launched Ninggiri. I think there's few more prospective sites. But let's talk about how can we leverage other form of renewables energy source, right? So I think Mr. John just shared how much of hydrogen potential that they're willing to export. So just to share, I think good news is all our new machines are future-proof for hydrogen. And I think that kind of approach may be good for grid, So we leverage on our existing, very highly efficient. It's considered latest in the system, 60% plus efficiency. So you can even co-fire or you can purely fire on hydrogen. I think that is one element where we still use the conventional machines, synchronous machines to support the grid. So it gives a good solution, but we have to wait when the price goes down, I believe. Not now. But definitely is something that we look at one point, I believe the hydrogen and BSS will intersect. I think at a good time frame, it will be equally competitive, I do believe, because we're going to leverage on the asset. The other element is, of course, we have good sites potential for pump storage. We can look at that, where we can push more solar during the solar hours up for pump storage. And I think the rest, wind is far short. I think it's far. Maybe somebody else has a better view of that, but I think it's a little bit too far to bring wind from the offshore. That's to what knowledge that I have.
So I think the MC, very shortly we're running out of time, so that might have been the last question. I'd just also like to note some of the potentials in the future, looking ahead around the potential for a renewable energy market between countries. I think is very interesting potential in the future. I think Malaysia's position on that for the time being is quite well known, but I know that Singapore has been in the market for renewable energy, and Australia is, of course, very prepared to be a supplier of renewable energy. We have conversations which John is very aware of around sun cable, exporting solar energy from Australia to Singapore and other markets. These things have got a lot of work and a long way to go, but when you look at the potentials within countries, looking at those prospects for sharing over time, I think are very exciting and present further challenges for grid operators one way or another in terms of both the availability of your supply and what might be available from overseas. But maybe I'll just leave that on that note, unless anybody really wants to comment on it. I know we're out of time, but I really wanted to thank all of the panelists for your presentations, for very stimulating presentations and discussion. I thank everybody for joining us here today. As we said, this is the future. It is happening. It's extremely important, and it's great to know that we have people like our panelists working on it for us, keeping the lights on, and doing so in a more environmentally friendly way in the future. Can you please again thank them all?
Ladies and gentlemen, we now invite Dr. Ning Azmin